basically Arduinos that have been programmed to run G codes. MakerBot is a little bit different.
And what is a G code for those that don't know?
A G code is basically it's like a movement coordinate system that basically you send this to your electronics in your printer, and if it says G something, it moves it. It might move one axis, one distance, and then another axis, another distance. So it's basically it's just a bunch of codes that tell your printer, move this stepper this way, or move this axis this.
Yeah, it looks like Jaxhax.
Jaxhax. Right, so essentially G code is just translation from a 3D CAD file in a computer to stepper movements to make the printed object.
Yeah, it's kind of like how with printer you get a postscript that will do some.
Right. That's good. It's like the equivalent of PostScript for like laser printer.
Yeah.
Okay.
You're only speaking two-dimensionally right now, though, right?
What is it?
You're only speaking two-dimensionally right now, though,
Well,
right?
let's go later this time.
Let me explain this other part.
Well,
So before you actually get something into V codes, I'll take a 3D model and I'll push it through a host software, which basically it'll look at my 3D model and it'll split everything on the z-axis going up into its own layer. So all it's doing is it basically just looks at slices of a 3D model going all the way up, and then it sees, well, we only have this much here, this much here, this much here, and it basically just puts more. It extrudes plastic in different areas just based on a two-dimensional sketch from the 3D sketch. And so each time after it extrudes in each of the two-dimensional places, then it just moves up on the z-axis and then it does it over again. So it's like, I kind of think of it as like a cartoon maker. You know how they have like a flip book? And if you want to make an animation that's going to do a different thing at the end of it, but basically what you do is you make this flip book that has a bunch of very similar pages. So if you're drawing Mickey Mouse running, you'll draw Mickey Mouse on one page, make another page that has Mickey Mouse with his foot move just a tiny bit, and then you keep going until Mickey Mouse is all the way until he's moved or something. And this is basically the same thing. You're basically just making a bunch of two-dimensional sketches that add up to one large three-dimensional sketch.
Similar to how CAD scan works.
Yeah, it's almost, that's actually very close. CAD scans, and then they also have another type of scan that's yeah, I think CAD scans are a lot closer because CAD scans actually
do
yeah,
layer by layer. They'll
right.
do like millimeter thick layers and then add it all together to make a three-dimensional, which is the reverse of G code.
Yeah, it's basically the reverse of G code. But I think MRIs are different because they look at like the entire thing, right? So that's electronics, and then in the MakerBot, they actually have individual stepper controllers. So each stepper in the printer will actually have its own electronic piece that will take codes from the main Arduino motherboard, and that'll send it over to the stepper controllers, and then the stepper controllers figure out, well, only this one's moving this way, and then it sends it back to the printer or to the stepper. And then one of the things that makes up CNC machines and 3D printers to a big extent is stepper motors. In most 3D printers, you'll probably see a NEMA 17 stepper, and they're very basic. They only take like about an amp worth of power. It's not really a big deal there. And then timing belts. So for every single axis, you're probably going to have a timing belt of some sort. MakerBot is a little different. is they actually have this threaded rod that's attached to one of the steppers, but the other three all have a timing belt. Basically, a timing belt is it's measured out and has specific notches, so that every single time that your stepper motor moves, 10 degrees this way, it'll only move that timing belt, 10 millimeters or so. Yeah. So it's very precise. You can get it down to like about 1 millimeter worth of movements, or 1 millimeter steps going either way. So it's pretty precise. And then end stops. We have 3 separate end stops. When I first got into 3D printing, I thought for sure that there would have to be 6, because you would need 2 for each side of the axis. And I've got 1 on here, but basically what happens is your printer will start in home position, and I'm not going to print this all the way down, but so it would start all the way down here with all of the end stops.
So basically, an end stop is a sensor that tells the printer that this axis has moved as far as it can go in one way.
Right. So if all these end stops were activated right now, it would know that it was in the home position and that everything was on that one central plate. And then when it starts off, it'll basically just add on to 0, because it knows that if all the end stops are zeroed out, then all it has to do is just add on to it and then subtract. So it's a lot of math after that.
Right, so it can take 500 steps to the left, but no more, and then it doesn't need to stop over here to tell it it's done. It knows that it's done, so it can't go forward.
Yeah. Big numbers stay under.
Right. But then, on the other hand, if you were printing something that was a larger volume than what your printer could allow, your printer wouldn't know that, and so you wouldn't know that it was screwing up until this was hitting the other end
and saying pushing a bunch of crap all over the place. Okay.
So I mean, that was kind of why I thought there was going to be another end stop. When I first got into it, I didn't understand how it was actually going to precisely print out. I thought there would almost have to be some sort of feedback system with like wires and pulleys to understand where the actual extruder is every single minute. But you don't actually need that. You just, as long as you know the origin and you understand that you're just adding in different dimensions, then you're set.
Yeah,
So the stepper
you can
motor,
actually keep it XYZ
Yeah.
on the program.
right? Because the stepper motor itself knows how many steps it's taken, and then after you tell it how many steps to an inch or whatever, it can just reckon how far it's moving.
And for whatever reason, when I was first working with Huxley, after every single layer, it would go all the way back to origin, and then it would go all the way back to printing. So it would, to try and explain what was going on with it, it was basically like, it would set down a layer, and then it would
Rush back over it.
And this would take like hours, because it would just, because one layer is a very small, like 1 millimeter. It's basically moving up 1 millimeter each time that it prints. And then after every 1 millimeter extrusion on top of that, it would move all the way back, reset itself, and then start printing again. But then when I first started with MakeBot, it was, instead of having that long relapse time of resetting and then printing again.
Right, it might take 10 seconds to move everything all the way back to start.
Well, it was more like real time. It was just, as soon as it set down one layer, it would move up and then start printing.
No, I mean,
what's it?
for the next one.
Yeah.
It would take like 10 seconds or something like that to cycle all the way back and then go back out again.
No, it'd take like 2 minutes just to cycle every single time.
Yeah.
And then, axes. There's 3 axes to every single 3D printer. Can't be any less than 3 axes.